how to heat up your house with compost, or how to heat up the greenhouse with compost. That's what we are talking about. Actually, we had a machine that's way more efficient than like the normal composting. Look, so 1 pound of organic matter, like half a kilogram, it has 2600 something watts in it. 400 pounds, like 181 kilograms of organic matter, let's say hay bale, straw bale, leaves, sawdust, and you can turn it to 1 million watts. And I'm showing you how to do it because this method it's way better than hot composting. So I will show you step by step what's the catch or how to do it, what's the blueprint, like exactly what to do. Like I give you the recipe, the blueprint. Just like the cold composting, and everybody knows that the hot composting heats up things way better. And the only thing that I will show you in the video, how to make like the hot composting, like how to bring it to Formula 1 levels. And it will be like 65 degrees all the time. Actually, it's not a compost, but let's say what you put in the machine, it will be decomposed mostly to carbon dioxide, like CO2, and it will decompose to heat, like nothing else. Sure, I kind of exaggerated, but that's the idea. So you won't have the byproducts, you won't have the laughter gas, you won't have like dangerous to humans and for plants, and you will have just heat, CO2, and basically that's it. So I put the recipe on the image and I will zoom out in a moment and I will show you column by column what to do, but first let me explain you like how it works or where everybody messed up, like where we were like messing up with the bacteria, why we killed them, why it didn't work. The recipe is kind of simple, but we need to measure like 6 or 7 things and we'll be able to gain way more heat and clean CO2 without the methane. So the hot composting, like the classical hot composting, is has an issue because things start to warm up and after like 2 or 3 days it will die back. And our machine will do nothing else, just keep the thermobacteria alive. And the biggest problem is with the thermobacteria is that they need the heat and they need the oxygen, and way more oxygen than we imagined. And the problem with like the normal compost piles is that the bacteria that will produce the most amount of heat, it will die down like in a day, 2 days, maximum in 3 days. The second you turn the pile, it will cool down the pile, the thermobacteria will die on the instant because they don't resist under a certain temperature. And it's like a sinus curve, you know, it's going up and down and up and down and up and down, and we are not doing that. So our pile will be at like 65-70 degrees Celsius, basically like the maximum that you can go, and it will produce the most energy that we need. And we need to measure like 6-7 things, like the CO2, the oxygen levels. Sure, we don't measure all of them, but we need to measure like 3 things for sure, and we need to adjust the machinery, the air intake, the air outtake. And before I show you the exact recipe, because we have it already there and I will zoom it in a moment, I just want to frighten you actually how much oxygen this heat-loving bacteria need and how much CO2 we need to eliminate. The numbers are insane. 120 pounds of organic matter, like 54 kilograms. Just listen here, it will be amazing. It needs so again, 120 pounds of organic matter, like 54 kilograms, it needs 237 square cubes of air to provide the oxygen needed for the bacteria. Can you imagine? That's like insane. 54 kilograms of organic matter needs 237 square cubes of air just for the oxygen. And here's the catch. The oxygen is one thing, but the other thing is the CO2. The CO2 is killing the thermobacteria. So when you turn the hot compost, you turn it because if you're not turning it, then the bacteria will die because of the CO2, you know. But when you turn it, you cool them down, but I don't want to go like ahead. Just listen. You need to eliminate the CO2, and for eliminating the CO2, you need to provide them 466 square cubes of air just to eliminate the CO2. Like, that's insane. And you will gain 360 kilowatts of heat and 79 or like 80 kilograms of CO2. That's insane, isn't it? Like, the numbers are like insane, and that's why it's not working. It's not working because when you have the compost, like the hot compost, you turn it, and what happens? You cool down the bacteria, and when you cool down the bacteria, everything dies. They die on the spot, and the whole things like shatters in like pieces of glass. And afterwards, a few days later, it will start to go up again. But with this machinery, we'll keep the bacteria alive. So let me show you the blueprint, and I will exactly explain you what happens in the machine and what should happen to get out the most heat possible, or like the most CO2. So I divided the information in like three videos more probably. So in this video I will show you exactly what happens in the machine, like the algorithm, like that happens with the bacteria, so you need to give them air, or now you have to take out the air. Now it happens this, now this type of bacteria dies, now another type of bacteria comes to thrive. So we talk about that. So basically that's the core of so that's the essence. After this video I will make a video about how to calculate like the fan speeds, how to calculate the energy needed, how to calculate how much CO2 you will gain. And in the third video probably I will talk about nothing else, just like the engineering, you know, like the architecture of and the versions, like which version is better for what. So that's how you heat up your house with compost, or like that's how you heat up your greenhouse with compost. So that's the algorithm, and now we start to zoom in, and we start from the left and we'll go to the right. So just ignore everything because maybe it might look overwhelming. Just focus in my eyes and I will explain you. So look, from up to down, it starts with a lower temperature, like let's say 10 Fahrenheit, minus 20 degrees Celsius, and the temperature starts to go up. And you have like the blue, that's hot, the yellow, it starts to warm up, and the red is the red zone that we want to achieve, like for the thermobacteria. Below that, they die. After, they die. So that's our sweet spot. So the whole machinery does nothing else, just keeps the hot composting alive. So look, what happens? There are, let's say, 3 types of bacteria. I'm not able to read that. 0.5 something, the cord-loving bacteria. And they start to work like at minus 10 maybe, and the only problem is they are not decomposing almost nothing, and they are producing heat, but like almost nothing. So it's like something that we can't rely on it. And when we have the compost on that in that spot, basically it will start to decompose like really slowly, and it's not producing heat. So we don't have the bacteria that we want, and that's why when we have the outside compost piles, it insulates the inside. However, the whole compost is not working, and that's why our method is genius, because in our method the whole compost pile will like be insulated, and everything will work, you know. So every droplet, it will be at 65 degrees, you know. It won't be like an inside or outside of the compost. It will be one big thing, and it will rotate, and it will be rotated. You have to wait and you have to insulate it, because if you're not insulating the whole thing, and I will show you how, but if you're not insulating the whole machine, you won't get the mesobacteria to start to work, to warm up the compost. Let's say the mesophile bacteria that you see there, like the yellow, that's called usually the cold composting. So it goes from 90 degrees Fahrenheit to 115, like 32 Celsius to like 46. And our problem here is it's decomposing. Yes, we get the heat, it's good, we can warm up things with it. Let's say it's more efficient than nothing, but it's not the best. And we have methane, we have the laughter gas, and all of the viruses and all of the bacteria that we don't like and we should be afraid of it, they are there. So actually that mesophile bacteria that's decomposing, it doesn't have that much power to kill the harmful bacteria to us humans. And if you insulate it, we will get the thermobacteria working like almost on an instant. Even in the coldest winter. So in the blue zone, you do nothing else, you leave everything as it is. The only thing is like the big difference that nobody does, that you have to insulate it. Like 10-20 centimeters of insulation, that's like 4-8 inches, something like that. And you really want to preserve heat. You close all of the machinery, you're not giving air to the machine, you just close it. Nothing else, you know. It's really simple. And afterwards you just wait and wait and wait and measure the temperature. And the only thing here you need to know, it's just the temperatures, like absolutely nothing else. You don't have to start anything, you don't need to have ventilation, you don't need to have nothing. You just sit and wait. Okay, so afterwards the big difference is when the thermobacteria starts to work, like we are in the good zone. That means all of the things in the inside will decompose, not decompose, actually will decompose back mostly to CO2 and energy. And I don't want to say nothing else, but it won't be that much of byproducts that with the cold composting. So we'll gain the heat. It will be something like the backward photosynthesis, because if you think about photosynthesis, it's nothing else, it's just making from energy and carbon, it's making organic matter. And now we do the same. So from organic matter we are making energy and carbon. So it's simple. And look, in the blue zone there's almost no heat produced. So I wouldn't recommend to take out the heat. So if you have pipes in it for the water, just leave it, and just leave it in the mesobacteria stage as well. Just let the pipe warm up as fast as possible to get to the thermobacteria stage, because if you're insulating it and you give the right material in the inside, and I will explain you exactly what to put in the machine and how it will change the temperature in the inside. But if you get to the thermobacteria fast, that means you're not throwing out energy, or you're not throwing out material for nothing. And I don't want to be like the most boring person here, like saying it like 1,000 times, but that's the second most important thing. You have to insulate the machinery. I don't say the pipe, the machine, because it's different. So if you don't insulate the machine, it won't heat up, or it won't heat up that fast. And when you start to rotate things in the inside, or when the whole machinery will rotate, you will cool them down. And I don't think it won't work, but it won't be that great. We don't have to be cheap here, we need to insulate it. It's just like simple, just remember, I have to insulate it with like 10 inches of insulation, or like 20 centimeters of insulation. Then it's really important not to let cold air or like air in the inside, because here the mesobacteria and the thermophile bacteria don't need oxygen. So if they don't need oxygen, don't give them, because the odds are you're like cooling down the pies. So what happens with the pathogens, with the viruses and the bacteria? So we have three different, basically four ranges. Like in the blue zone, usually that's like the outside temperatures, like the outside environment. It's not like particularly dangerous, or it's not like the safest. It's just, let's say, normal. The problem is that we should be really afraid of, it's like the cold composting, because that's like the yellow on the screen, because the yellow, it has our body's temperature, and most of the viruses and most of the bacteria that's actually harmful for us, for humans, it's there. So you want to avoid that at all costs. Not like you're dying, but let's say you should be afraid, And there it's like another stage where the pathogen starts to die. It's like when the thermobacteria starts to take over. That's actually the hot composting, because probably you know about it, maybe even better than me, which kind of animals, seeds, everything dies there. And the thermobacteria are so efficient that they actually start to eat alive the other bacteria, and they decompose the viruses. They don't kill them, because viruses are not living, but they will decompose the viruses, most of them, like almost all of them. Sure, probably there's like one that it's like surviving, but the main idea is the thermobacteria is not friends with the mesobacteria environment, and they will eat them alive. They will eat up everything alive. And that's it. And that's why we need to provide them the oxygen, because they need, and you've seen on the calculations, they need a lot of oxygen, and they need a lot of CO2 to be eliminated so they can work at their fullest. And the more oxygen and more CO2 you eliminate, the better the compost pile will work in the greenhouse, and you will gain way more heat, and it will be cleaner, because you won't have like the byproducts that we have with the mesobacteria. We won't have the laughter gas that much, if I'm sure here, and we won't have like the other harmful things, except the CO2, of course. In the next video I will show you exactly how to calculate the fans, how you need to calculate everything. Now I'm not going into that. So the only thing that you need to remember here, we have 4 stages. Like first stage, you close everything, you don't give them air. The second stage, you have like a small blower, like a ventilation system, like this small, like almost non-existing, or like you don't even put it there. Afterwards, you have like a smaller computer fan, then you have like a bigger ventilation like this one, you know. And afterwards, you can go for like a big leaf blower, something like that. So basically, it's like a quite big range of thing that you have to know. It sounds complicated, but it's not like that. You just have to know like, oh, it needs air, now it's not needing air, and you need to know about what type of material you have in the inside and how much heat you actually need to provide to your house or to your greenhouse. Surface area, it's really important, because let's say when you have chicken and pigs and you feed them and you put the feed in one place, can all of them eat at once? No, they can't. So it's the same as well. So if you have like small branches, thick weeds, corn, like things that are bigger like wood chips, the surface area, it's really small compared to the weight. So let's say like 1, 2, 3 bacteria can eat at a time. However, it's like if the same amount of material, it's like really small, like sawdust for example, or like freshly cut grass, that means that not 1, 2, 3 bacteria can work at a time, but like thousands or like tens of thousands of it. So they start to produce more heat, more energy, the bacteria start to spread even more. It's like an avalanche. I'm recording this section for like the 100th times, so please appreciate it. So if you have the biggest materials like small branches, thick weeds or corn, that means you will have like a really cold temperature the inside, because the surface material, it's not enough to host like tens of billions and trillions of bacteria. The smaller the surface area goes, or like the bigger surface area we have with small materials like with sawdust or like with freshly cut grass, the more bacteria can eat in the same time or like in the same place. That means they will produce more heat, they will start to decompose faster. Let's make up a scenario. Let's say you have in the machinery loam, grass, leaves, hay and sawdust, and it's like on for like 2 or 3 days, everything is working perfect, you are like melting iron in the inside, and afterwards you start to feed the machinery with tree bark, thin branches, wood, chips, straw, field grass. What will happen? It will start to cool down, because the surface area is like way smaller. That means less bacteria will start to chew on the food that we provide them, and even the nutrition in the food, it's almost the same, because it's not like a big difference. We won't have the heat because we will have less bacteria with less surface area. That means the whole pile will start like slowly but surely to cool down. And if the pile starts to go below like the thermobacteria's like sweet spot, that means the thermobacteria will die, and we'll have the mesobacteria, and it will work perfectly, and we'll have like hot water, we'll have like everything, but it won't be that efficient, and most of the material that we have, it won't be decomposing that cleanly that we have with the thermobacteria, because here the main idea is to get like the most amount of heat and the most amount of CO2. And one more thing to keep in mind is the carbon-nitrogen ratio, because the bacteria needs the carbon and the nitrogen as well, and probably you guys know way better than me, if you're gardening, that it needs to be a ratio to have like the best composting. And it's like the same as here, so it's not like a big difference because between the cold composting or like the hot composting. If you have the ratio, let's say 1:32, 1:35, or like 1:40, it would be amazing. When I did it the first time, I was like checking on the internet, it was like compost calculating something ratios, and I know that I calculated like that because I had hay bales and I had coffee grains, and I was putting, oh, I have that amount of hay bale, how many kilograms of coffee grains I need to have that, and the program just calculated it, you know. So you don't have to be like a scientist here, you just Google it, like compost carbon nitrogen ratio calculator or something like that, and you start to give it, and that's all. And the machine in the inside, I have 2 versions, like one, basically I built 3 versions. The first 2 versions the whole machine was rotating, you know, like this one. And the version that you see on the video, it's the machine is static, and inside I have some arms, and the arms it's moving, and I have like pros and cons, and I will make just a video about that, what was the mistakes I made, what was like the good insights that you should keep in mind. And basically that's today's video, and in the next video I will probably show you how to calculate the ventilation, like how much air you need to take in and how to make it that you're not cooling down the bacteria, because probably you will. So subscribe, and afterwards probably I won't be like a gardening channel, and I will go back to the real estate, because I like to talk about real estate. I like to talk about how to keep the heating bills down. That was just like a little hobby that I had for like 2 or 3 months, and I managed to to heat up the house with it. You can check the other videos, because I am showing there how I managed to heat up our basement. So that's it for today's video, and subscribe. And if you have a question, just write below or like contact me, and I will be happy to help you.